Okay, let's get started with today's lecture, ninth week, 2D computer graphics and design representation, design presentation, third week, okay? Here is what to do today, okay? We are still in design issues, okay? Especially focusing on 2D computer graphics, just before 3D. But actually, 2D, 3D, even 4D, and the actually no differences, okay? They are all something about design representation, design presentation, okay? To bring your idea from your head, from your brain, and present on top of specific design media. At this time, the medium is computer, application, software, hardware. So whatever it is, your design supposed to be represented, visualized using computing environment. That's the topic, okay? Actually, today's topic is, the reason I put just before 3D means we are going to deal with some specific three-dimensional modeling, geometric modeling tool, especially focusing on SketchUp. SketchUp as a modeler and V-Ray as a renderer, okay? So before dealing with such 3D applications, we need to take a look at some theoretical background and mechanisms we have to take care of on top of your computer screen. Mostly 2D, mostly some theoretical background, some related issues we have to deal with, okay? So just before 3D applications, actually we don't have time for, I told you before, learning Photoshop, learning Illustrator, learning how to do some desktop publication, desktop publishing applications, or some very fundamental 2D computer graphic issues. But this class introduces you and like to bring your attention for teach yourself in various kinds of applications in design development, okay? So that is why today I like to introduce you two apps. App usually means application, but we used to have amount of applications, computer applications, Windows applications. But nowadays, when you say app, even app derived from the term application, the app means mobile app, okay, or internet-based application. Anyway, two different type of apps we are going to deal with, okay, Prezi and Homestyler. And also we're gonna demonstrate SketchUp 3D. For demonstrating the issues we are going to deal with today, okay? 2D digital images, camera lenses for enhancing your photography, background knowledge in terms of photography. For what? Not for your Instagram, not for your Facebook, for your design development, okay? Developing your design skills and some design techniques, tools, and so on, okay? Quickly look at where we are. We are on the 9th week, 2D images, camera, lenses, and SketchUp 3D. We are beginning to use SketchUp as an application for design development and series of SketchUp. And some of today's slides will show you some examples for your final project, okay, by using SketchUp and associated tools such as Photoshop, AutoCAD, PowerPoint, Prezi, Illustrator, whatever it is you can use. How to develop your design idea, how to develop your design progress, how to develop your design visualization. I like to show you some professionals' work done by experts, done by real-world designers, existing buildings, existing designs. I like to show you from today. Anyway, some series of SketchUp related tools and midterm exam and final project. That's the schedule we have. Okay, before getting into the course, actually I want to show you this one first, okay? There are two approaches, okay? Two approaches. The term artist here means designer, okay? Designer. Okay, artist and designer, they are totally different, but let's assume that artist means designer. And learning program means, okay, actually learning program here means learning computer programming language. But let's assume that learning program here means learning design computing, okay? Learning how to use computing tools, how to use some advanced computing environments, and so on. Exactly what I'm saying in my course, CAD and graphics course, design computing course, digital design course, okay? So this man, you know who's him, right? This guy declares artist learning programming is better. And this man, you know who he is, okay? He's claimed that programming guy learning art is better. So whose idea you are supporting to? Do you believe designer supposed to be learning design computing or computing techniques, or vice versa, programmers, engineers, computer scientists learning design? Which one is better in your opinion? Okay, let's have a vote, okay? You have to raise up your hand. Left one. Okay, right one. Okay, you have no idea? Okay, again, anyone who's believing this approach is right? Okay, this approach. Okay, that's one good point, one good standpoint. But okay, let me say conclusion. In my experience and in my personal opinion, not only in my personal opinion, actually from diverse kinds of perspectives, many people say that, okay, I can say 100% sure that this is right, okay? And you are not sure why, actually. And you claimed that learning computing is something important or something hard work or something different. But actually, let's talk about this one. Artist, art, design, fine art, whatever it is, it can be one of the domain-specific issues, okay? Domain-specific issues means your domain, which means civil engineering domain, building science domain, interior design domain, or some graphical design domain, music domain, okay, entertainment domain. We have lots of different diverse kinds of domains, subdomains, okay? So some specific problems in each domain, we can say it's domain-specific problem, okay? Domain-specific problems, something associated with computing tools, IT, some advanced technologies, they always raised up and handled and also resolved by domain experts, okay? In this case, programmer or programming, someone who's skillful in programs, so-called general purpose experts, general purpose engineers. They are very good at their own or some general purpose problems, general issues, okay? Not on domain specific issues. So actually this guy is right, okay? Actually I didn't watch this movie. I don't know. I have no idea about these scenes. But anyway, my point here is lots of people believed left one is right, and in their empirical approach, that is something better approach. And actually the link is here, okay? The link, and there are amount of replies, okay? And I don't mean that these guys are totally right and they are totally expert and they are 100% sure. I'm not talking about that. But anyway, reflecting the opinion, common opinion, even in these replies, most of them are someone who's working in their own industry, own domain, own company. Okay, they choose number one. Okay, like this. Okay, so this is one of the proofs that I'm saying about this one. Okay, back to the slide. Small conclusion. Okay, we are in design domain, specifically interior architecture domain. Sorry, interior architecture design. Learning programming, learning computer tools, learning advanced technologies. That's exactly what we are taking now. Okay, so that's why I'm saying the more computing, the more design. Okay, that's current days things we happened. This guy has different background, so they can have some different perspectives. Okay, anyway, let's get into the course lecture for today. Today's first topic is photography, okay? Photography and design. Or think about photography and architecture design. The asterisk here means omittable. So we can put everything. Photography and interior architecture design for our department, for your major, for my major. We need to take care of photography. Let's take a look this kind of pictures from some very easy fundamental theories what you have learned last week. Okay? So let's think about this kind of picture in terms of grid system. Okay, you may put two more lines here. Okay, two more horizontal lines. Okay, and probably two more vertical lines. Okay, so this line and another line, roughly generated lines, are exactly on grid lines. Okay, and also this one is sort of right side vertical line balanced. Okay, in terms of grid system, in terms of layout issues, the visualization of this picture is so-called well balanced. Okay, so what if this picture is this spot is exactly located the center of this picture? In that case, this picture has no unique features, or there is no specific ideas. Just there is a picture, okay? Nothing special. But simply because the angle and the layout has well balanced according to my grid layout system, okay? I told you grid, there is invisible grid lines and your objects supposed to be laid upon those grid lines. And this one simply follows that principle. And you can take a look. This picture is, you don't know why, exactly why. You cannot explain so far. But now you can explain why this picture is looking comparatively stable and well balanced. Okay? And also this picture too, okay? Most of pictures here taken by me, okay? I took those pictures and this is me, okay? That's me. Really, that's me. That means this picture taken by others using telescope lens, okay? We are handling some issues about camera lens today. So let's take a look at this one. This is my office, San Francisco Autodesk. This picture is looking very special, okay? The the term special here means this special, okay? I believe you understand what this term means, okay? Special. This special means you can feel the depth of space, okay? The depth of space. Even if this space is small and cozy, anyway, through the lens, through the camera, based upon this digital image, we can feel very special, okay? That spatial area according to the picture. So this is the reason why we need to take pictures using wide lens, why we have to take care of angles and some proportions. So we're going to talk about this issue today, okay? As well as some technical issues. Also, let's take a look at this one. This is the Georgia Tech College of Architecture building, and I took this picture, of course. I used ultra wide lens, okay? And also, let's take a look some grid system, okay? Let's put vertical grids, okay, and horizontal grids like this. So there are some invisible grid lines, and you can find out some layout system. But anyway, the proportional layouts can be subdivided exactly based upon your 3 by 3 subdivided grid system, okay? What if this point or somewhere here is exactly placing on the center, on the middle? That is not a good angle picture, okay? Most of good angle picture has basic and fundamental principle. They always follow, at least, even not they are just golden ratio, at least they follow just grid system, 3 by 3 grid system layout they have, okay? And also this one taken by ultra wide lens. That is why the buildings looking some distorted, okay, exaggerated, distorted. And also take a look this picture. They are not professional pictures, okay? I took the pictures, but actually I followed very simple principle, okay? Layout system. We have 2 more invisible grid lines here, and also 2 grid lines for vertical, and then objects, layouts exactly following such invisible lines. And then we can feel this picture is looking stable and well balanced, okay? In other words, good pictures, okay? So far, you couldn't understand and you cannot explain why, but hopefully, thanks to the theory we take a look last week and including today, you can mention why the picture is looking stable or well balanced in terms of layout system. This is Chicago, okay? Also, I took this picture. And also, I took this picture at Arizona, Scottsdale, using telescope lens, okay? Ultra wide lens versus telescope lens. That's exactly what you are looking today. And we need to take a look some camera and lens issues. Okay, so far I showed you some example pictures taken by me. But why we need to know something about lenses or something about photography issues, ultra wide lens, telescope lens, and the focal distance of the lens. Why? Because we're going to deal with computer visualization, so-called computer rendering. In terms of computer rendering tools, there is camera. And the camera has, take a look, this is camera parameters defined in 3D Max at this time. Stock lens, take a look, 15 millimeter, 200 millimeter. Okay, which one is telescope? Which one is ultra wide lens? Anyone who has DSLR camera? DSLR camera? No one has DSLR camera yet? Okay, in near future, you're gonna have DSLR camera or some mirrorless camera at least. Anyway, small numbers, so-called 15 millimeters or 16 millimeters, they are ultra wide lens. 200, even 300 millimeters, they are telescope lens, okay? So let's take a look why. Take a look, 50 millimeter focal distance. Focal distance here means there is retina, human eye, or we can say sensor, because we are dealing with this one in digital camera, okay, DSLR. So this is the sensor, image sensor, and there is the lens. So let's take a look. 50 millimeter focal distance compared to 85 distance, 85 millimeter distance. In this case, take a look, the size of the object. This object and this object exactly same size through this sensor, through this retina, through the eye. But this one has 85 and this one has 50 focal distance. In other words, in same distance object, we can say wider view, okay? This one comparatively narrow view, okay? Physically same distance from human eye, but we have wider view, narrow view because of this mechanism, okay? So there is concept of field of view. In today's lab exercise, by using SketchUp, you're gonna make some different field of view, okay, today. Anyway, field of view here means the angle of degree of your view, okay? So this is wide lens. That's why we are saying wide lens, and this is, we are saying telescope lens. Let's take a look. We need to use wide lens. Sometimes we need to use telescope lens for spy shot, paparazzi shot, whatever. But anyway, why we need to use wide lens? The lenses have pros and cons. Good to view all and looking professional. That's the pros of wide lens. But cons, distorted, okay, exaggerated. Something wrong sometimes because of wide lens, ultra wide lens usually. But how about telescope lens? We can zoom in, but it's very narrow. So okay, let me search. Okay, ultra. Okay, telescope lens in image search. Let's take a look. This size of the lens. Okay, this lens, this length of the lens going to be attached to your camera body. Okay, why this one is so long? For getting longer focal distance. By using short distance angle camera lens, we cannot make, okay, let me show you the lens here. Okay, this is so-called bundle lens, okay? Bundle lens, which has very standard focal distance, 18 to 55, okay? This is typical size of the lens, and this is 50 millimeter for portrait, okay, portrait lens, very small size. But, okay, let's take a look. This lens, this is telescope, okay, 200 millimeter telescope lens. That's why it's kind of long, so longer distance, 200 millimeters. Of course, internal mechanism is really complicated and something different. But anyway, that one is telescope lens. And this one is the main lens for today. This is ultra wide lens, okay? The most expensive one, okay? Entire, all the lens and the body, they are not that expensive than this one. This one is the most expensive one, including all others. Okay, anyway, this is ultra wide lens. And someone like you, what I mean is someone who's studying, majoring architectural design, especially interior architecture, you need this type of wide lens, okay? This one supports 10 to 20 millimeters, ultra wide lens. And I like to demonstrate, just a second. Okay, just a second. I'm gonna show you demonstration of this lens, okay? Just for your information, I like to show you demonstration at first. Okay, just a second. Okay, as you see here, this is 18 millimeter, and it's kind of okay. Okay, this is 55 millimeter, okay? 55 millimeter, okay? And let me show you the telescope lens, okay? Okay, so this is actually 75 millimeter, and this is telescope, okay, 200 millimeter. So this one is very good for spy cam, of course, but paparazzi shot. But this one is not for you. This one very good for watching birds, okay, or something activities. Okay, let me show you what you need. Okay, this type of wide lens. Okay, let's take a look this wide lens. Okay, 10 millimeter wide lens. Okay, by using this lens, okay, this lens shows you very spatial. Okay, the term spatial, not SPECIAL. Okay, spatial lens. How about this one? If you take a look like this or something like this, you can make something very exaggerated and distorted like this. Okay, distorted view. So this lens is the lens exactly what you need. Okay, so 20 millimeters and 10 millimeters. Okay, take a look. the picture is looking very special, and some, in terms of architectural standpoint, this one is so-called cool pictures. Okay, so you can use this kind of lenses in order to make your scene looking architectural. Okay. Okay, let's go back to the course material and let's take a look. Example. Okay, sorry, just a second. Okay, let's take a look. Example screenshots. Take a look. 200 millimeters. But this is not a picture. What is this? Actually, you can make your scene in computer tools. At this time, it's 3D Max. In 3D Max, you placed the 200 millimeter camera, okay? And you changed 85 millimeters. Okay, this is 85 millimeters, and this is 50, 35, and 24 millimeters. You should remember 24 millimeters, simply because it is close to human eyesight, okay? So whenever you see some interior scene or actual building interior inside indoor of the specific space, you can see this angle of view, okay, through your human eye. What if the wider angle compared to 24 millimeter? In other words, shorter focal distance compared to 24 millimeters, such as 15 millimeter ultra wide view. This is very special, okay? The term special that I wrote on the whiteboard. Looking very special and looking professional, looking architectural. So the pictures you are watching on top of design magazine, architecture magazine, interior design magazine, any single picture in such professional magazine all are in this angle, okay? Especially for interiors. Of course, some pictures can be some different angle, different focal distance, but most of them has this ultra wide. Sometimes, what if shorter than this focal distance? In that case, what we call such lenses fisheye, okay? They are fisheye lenses, but it's too much distorted, too much exaggerated. That's why we need something wide lens for architectural design and representation. Okay, anyway, even if you don't have DSLR, even if you don't know DSLR system, even if you don't have any lenses, you must know the mechanism of lens, focal distance, and some related technologies. Why? You have to use some similar lens system for rendering, for visualizing your design, okay? In 3D Max, in SketchUp, today's lab exercise, or any other tools. That's exactly what you need to know. Let's have a comparison between 50 millimeter lens and ultra wide lens. Okay, if you see this picture, it's not easy to depth of the space. In other words, it's not looking so special, okay? But at least you can find out some objects defined, taken in this angle, okay? You can see objects without any distortion, any exaggeration, okay? You can see as they are in the scene like this. And also take a look some lines, okay? Especially vertical lines must be orthogonal, perpendicular. In other words, 90 degree. Take a look this one, ultra wide lens. Very effective to create space perception, impression of space. But you should be careful. Avoid too much distorted or exaggerated, okay? Take a look. too much exaggerated compared to this one. The distance between this point to this one is looking like really, really long, but actually it's not, okay? So this one is exaggeration, something wrong, distorted. But anyway, we can feel the depth of space. We can perceive the spatial depths. That's the reason why we need to take this kind of picture or this kind of render scene, okay, using wide lens. Even in this angle, even if it's two vanishing points, 2-point based perspective, vertical lines always perpendicular, orthogonal, 90 degrees. That's important point I mentioned before. Okay, picture example. Let's take a look at again that I showed you before. My office, okay, also taken by this lens, okay, 10 millimeter ultra wide lens. Take a look, vertical lines, always 90 degrees, okay, perpendicular. That's the point. Take a look this one. The line here and line over there and the line for this column, all they are parallel as well as exactly 90 degrees perpendicular, okay? And this is something different and some more angled pictures. And the last one you have to take care of is depth of field. Actually, so far we are dealing with some field of view issues, okay? Field of view. But field of view, depth of field, something confusing, looking similar, but totally different, okay? The depth of field makes your scenes photorealistic and professional. Let's take a look at this picture. There is camera, okay? Usually, your depth, as a default, your depth is very deep. In other words, even close object, some far objects, they are all looking clear, okay, in focus. That's default. But sometimes we need to use shallow depth lens, shallow depth rendering, shallow depth view. In other words, your focus zone going to be very shallow. That is why we are saying shallow depths, okay? But in general, deep depths, that's the default. Let's take a look at this picture. Actually, I took this picture in Autodesk Gallery, San Francisco. This is designed by Zaha Hadid, and this is 3D printout object. So let's take a look. In this picture, you can find out focus zone is very narrow. All others are out-focused. This is so-called out-focusing, okay? Out-focused picture. So focus zone, very narrow, very shallow depths, and out-focused. How about this picture? The same view, same object, but this one has different focus zone, and this one, some rear part focus zone, okay? Focus zone is here and totally out-focused. Totally different visual effect. Okay, they are pictures. You can take this kind of pictures even by your smartphone. Nowadays, smartphone supports this kind of out-focusing, right? Especially for macro or something like that, pictures. Anyway, you can take this kind of pictures by using DSLR, digital camera, lenses, whatever. How about computer renders? When you render this kind of scene, this is default, okay? Deep depths, everything in focus. But actually, you can put some shallow focus zone like this. If you control your camera lens for narrow focus zone, to focus this column and all others going to be out-focused like this. It's looking coarse because the render option is not that high quality, something mid quality. Anyway, some different focus zone is here, and next one has different focus zone here, okay? Shallow depths. Focus zone is here. And all others out-focused, okay? But actually, the best way of making this kind of scene is using Photoshop, because rendering this kind of scene in renderer, I mean mentally in 3D Max or V-Ray, SketchUp, this one going to take almost 1 hour, 2 hours, very slow. But you know Photoshop, you know how to select, how to put feather, and how to invert selection and Gaussian blur, okay? So this is the output of Photoshop, just 1 or 2 minutes, okay? Much faster and visually effective, much better, okay? Focus zone here and all out focused, done by Gaussian blur, okay? That is why we need to use Photoshop, image retouch. Exactly what we have learned last week and 2 weeks ago. Anyway, the concept, depth of field, described those slides. Okay, let's have a break, 10-minute break, and move on for the, have a nap, okay, and wake up. Okay, let's finish quickly rest of the slide today and move to the lab exercise for today, okay? Professional interior photography examples from Interior Magazine, BOB. Some professional magazine for interior architecture design globally named BOB. The magazine BOB, of course, contains amount of pictures as well as 2D graphical designs for maximizing the meaning of designer's intent for real-world projects. In other words, here are some examples of professional design representation. Professional design presentations. What is your final project? Your final project is going to be design representation, design presentation using PowerPoint or Prezi, whatever, some slide. Of course, your design is supposed to be presented by you, but this is design computing course, not design studio course. So, not your design, okay? Designers design, existing design, professionals design. So the series of designs that I introduce you today are the possible subject for your final project, okay? You can pick some of them for your final project, okay? Okay, let's take a look. Take a look at the layout. Actually, this is magazine book, which means exactly on the middle there is folding line. This is book, okay? So the book's supposed to be folding like this. So there is folding line, but anyway, it doesn't matter. This is PDF file, image file that we create. So let's take a look. Here is the project name, design name, Konoba Restaurant and Bar, of course, and some index information, which contains designer name, design firm name, construction firm name, engineer name, location, country, area, and so on, okay, photographer, editor, and so on. Some concept description in English and Korean, as well as some hand drawing or computer generated conceptual diagram. And this is, of course, the last picture for after the construction, after the design, realizing the design. As you see, the concept of this one is some fishes, okay? It's dynamically moving fishes and some ocean-like design concepts applied for elements in this design. Anyway, take a look at the layout and the picture design. All are perpendicular, okay, vertical lines, and layouts of the picture, layout of these pages, 2 pages, all they are looking so-called professional, okay. Second page also has a series of pictures, including floor plan, and so on, okay. You can find out professionally represented design for this one. The next case, color photo megastore. Actually, take a look. some bluish colored ceiling structure, very unique, but all of them are very sort of cubical. In other words, some cubic box-shaped design, some pattern design. Not that unique, not that uniform, but anyway, this one is looking very spatial. The term here spatial, okay, spatial. Why? Simply because the lenses, focal distance, they all are ultra wide, okay? Take a look. Some exaggerated, ultra wide lens. Take a look. Distorted. This one's supposed to be exactly rectangle size, but this one is looking distorted. But anyway, this one looking very spatial. So it's wider than human eyesight. In other words, 10, 15, 16 millimeters ultra wide lens used for taking those pictures. So for your rendering, for your visualization of design, what if you want to show some visualization in spatial perception, something looking spatial, something deep depths of the space you want to express. In that case, you need to use this kind of short focal distance lens. In other words, wide lens you need, okay? Because actually this is not a big space. It's kind of small retail shop for cameras, okay? Small retail shop. But you can find out this one is very special, very deep, very wide, broad, and something high ceiling. But actually it's not that high ceiling. But anyway, looking very huge area, even if it's very small size retail shop. Okay, next one is, okay, again, take a look. Vertical lines all are 90 degree, perpendicular, orthogonal. That's very important principle, okay? Next case, Academy of Swiss Museum, Berlin, designed by Daniel Libeskind, okay? Take a look. Okay, this one is looking angled because the real objects, all objects, they all angled, okay? Very unique and something exceptional design. Usually this kind of wall structure all day is supposed to be 90 degree perpendicular, but in this real design, take a look, angled, okay? Angled walls, angled interior structure, and some angles used for making interior facilities, wall structures like this. So you can find out some angled walls somewhere around, somewhere here. Okay, all those four has some angled walls. That is why the wall line and bottom line, ceiling line, they are looking different. Okay, next one, Forte Nanshan, China. Take a look. Very linear structure of spatial, that term spatial lobby area has the unique design features, but also the elevation, I mean some wall structure has something diagonal shaped, triangular shaped, some identity applied for this design, okay? Something like this. Next one is Starbucks coffee retail. Really, really small Starbucks coffee retail located in Japan. Actually designed by Kengo Kuma, okay? Very natural looking design. You can stop by this Starbucks coffee when you stop by Japan. Anyway, but take a look, this picture. This is main entry of this Starbucks coffee retail. Looking spatial, looking very deep, looking big. But actually, take a look, really, really narrow and small size Starbucks retail store. Take a look, the sitting zone, sitting area, and the bar area, very small, okay, narrow. But because of the wide lens used for taking the picture, this one is not that looking small space, okay, looking spatial. looking deep depths. And you can find out this structure, something bird nest looking structure, wooden structure, thanks to the picture you can see in those series of images. Next example, Walmart.com office. Okay, you know what is Walmart, but this is Walmart office, not Walmart retail store. Anyway, take a look. Series of offices, meeting conference areas, working zone, different style of visualization for photographic pictures taken. What if you have to create the space, not entire space, some of the space, okay? And try to focus on this area to visualize your design concept in your renderer, in your SketchUp modeler or Rhino, whatever it is. You have to create geometric model and visualize something similar to this one. In that case, you have to make sure that you have some sense of camera lens. You have to figure out the mechanism of wide view, narrow view for making your view spatial, okay? That's my point. Genesis commercial building lobby. Take a look. This lobby has very unique design feature, okay? Human hand-like object. This one is kind of non-human scale, okay? Something exaggerated, enlarged scale of the object. For figuring out the size, the dimension of this structure, we need to carefully build some other environment like this. And take a look, some spaces motivated by Space Odyssey movie film, and some specific zone, area, exhibit area, and so on. All they well represented by those given pictures, but those pictures should be replaced with your renderings, your visualizations, your designs, your representation, so-called design presentation material created by you, okay? That's one of your final project. Take a look, this unique structure, unique furniture, this one. You can be sitting down this furniture. This is furniture and elevation structure, interior components, very unique design component for this space, this area. Some more pictures, and you can find out this chair, Phantom chair, one of the famous design chair, okay? Phantom chair also used in this space, like that way. More pictures, and take a look. Actually, this is not a small space, comparatively big space, okay? According to those given floor plans, you can figure out the area of the space. Okay, so far we have looked some professional design representations. So those designs, okay, this one generated by probably AutoCAD or similar CAD drawing tools for making those precisely drawn floor plans, okay? Of course, all of them are not hand drawings, okay? None of them drawn by hand, all of them created by computers. AutoCAD or similar drafting drawing tools. So for design and design development tools, what kind of tools available? Okay, in my course, in my design computing classes, we're gonna use mostly those tools, okay? At the beginning of the course, this semester course, CAD and graphics course, we're gonna deal with computer tools with SketchUp, V-Ray, Photoshop, and something more, okay? Next semester or next year, you're gonna deal with SketchUp with AutoCAD for professional design development based upon actual studio work, okay? But the main objective of this course this semester is to enhance your fundamental computing capability, as well as your bringing your attention, bringing your interest to learn by yourself, teach by yourself in design computing area regarding design issues, okay? Anyway, later on, we're going to deal with 3D Max, complicated 3D Max interface for making photorealistic rendering, animation making, and so on. At the end, some BIM tools, okay, BIM tools using Revit, Dynamo, Grasshopper, Rhino, parametric modelings, lots of complicated tools we are going to use, okay? But actually, in each May, in every year, every spring, exactly right now, take a look. AutoCAD 2017 is the latest version, okay? You can download AutoCAD 2017 because it just released. So every spring you can get Autodesk next year version. What if your newer version released? You have to learn again and again. If you stick to the interface issues, I mean, if you are sticking to which button you have to click, the clicking sequence, clicking orders, if you understand only the user interface issues, some technical aspect issues, and then whenever newer version released, you have to learn by yourself, you teach by yourself again and again. Very recursive and time consuming, okay? Even if you are very familiar with AutoCAD 2016, 2015, if 2017 released, you have to learn again because they are looking different. But what if you have known background theory behind the technologies, related techniques and theories you have to know? In that case, you can comprehend what's behind. So front-end issues, I mean user interface issues, just nothing, okay? Just 1 or 2 hours you need for learning which button is what for, something like that, okay? And then you can learn by yourself easily, quickly, without any problems. That's my point, okay? But actually there are, okay, those are the applications, computer applications, PC versions mostly. But actually nowadays we are encountering totally new environment in computing. For example, cloud computing, something internet and network access environment available. And also this kind of mobile and tablet, even smartphone interface we have. And also BIM, building information modeling, or something advanced domain-specific tools available, even by the web, okay? For example, Homestyler PC version, okay? This one is looking non-professionals tool, okay? But actually, even if it's looking non-professionals tool, output of this one can be professional, okay? And this is really, really advanced technology. In the lab exercise today, I'm going to show you, and you have to design something and submit your own design today. They are all 3D, and if you request 3D render, Homestyler will generate this kind of 3D render scene rendered by cloud computing, not your computer, okay? And send this image to your email account. So you can get this kind of image, even 360-degree renders, okay? Something virtual reality environment, something VR, or something photorealistic render for something like game or navigation environment, and so on. Okay, this is the autodesk-homestyler.com website interface, no tools installed required, no ActiveX, no Java installation, no additional plugin you need. Just open the website and you can design. You can request save, request render, request file download, AutoCAD plan download, something like that. For example, this one is Homestyler 3D design in 3D view mode, or you can open this one in 2D mode, okay? This is 2D mode. In 3D mode, if you request AutoCAD file, you can download this file, okay? AutoCAD generated drawing file. Totally based upon your drag and drop based interface, and you can generate AutoCAD file as well as Revit file. So today's objective of lab exercise 1 and 2 is to show you nowadays advanced technologies for supporting design. Okay? Okay, AutoCAD, Revit, SketchUp, Rhino, Grasshopper, some other related professional tools. They are something design or design development tools, but don't ignore this kind of layman's tool. I mean, some non-professional tools like homestyler.com or something like this one, Chief Architect, okay? There are amount of more options, more applications, more software available. Something is commercial, something is totally free. But anyway, you can download and get and use some demo version software free. What we need to know is there are lots of applications available and very advanced tools available, and you have to know what kind of tools you need and main aspects, major pros and cons you can take advantages of using such applications, distinguishing different objectives, and so on, okay? That's my point. Okay, let's move to the lab exercise, okay?